Welcome back to MathSpark. In this video, let's take a look at the second of the three active homeworking problems. So we were talking about the following two things. Our paradigm shift for what homework is. It's not just how we practice, but also how we present our math ideas, and our problem-solving process. Last time we took a look at example 1, so this time we're going to focus on the second example. So let's grab our piece of scratch paper and begin. The first step in the process is to understand the problem, so let's copy the problem down. The function f of x equals 18 over x plus 6 is 1 to 1. Find an equation for the inverse function, f inverse of x, or f to the negative 1 of x. So the first thing I want to do is understand what this problem is asking. Now a function I know is a machine who converts inputs to outputs, so this function right here takes any input value x and returns the value 18 divided by x and then adds 6 to it. For a function to be 1 to 1 means that it passes the horizontal line test. That is, no horizontal line intersects the graph more than once. As for the phrase inverse functions are two functions who, when composed with each other, return the value x. So g of f of x is x and f of g of x is x. I know that for a function to have an inverse, it needs to be 1 to 1. So the first sentence about the function f of x is simply telling me that it does have an inverse. The second sentence is asking us to find it. So at least I have some idea of what the problem is asking. Now what's going to be my plan? Fortunately for my algebra class, I know that there's actually a step-by-step process for finding an inverse function. And the 4 steps are: write the equation y equals f of x, switch the roles of x and y, solve the new equation for y, and then the result will be y equals f of x. So let's put that plan into action. So we'll start off with the equation y equals f of x, which in this case is 18 divided by x plus 6. And now I need to switch the roles of x and y, so x is equal to 18 divided by y plus 6. And now I want to start the process of solving this equation for y. So I can subtract 6 from both sides in order to get x minus 6 is equal to 18 divided by y. To get rid of those denominators, I could multiply both sides of the equation by y, which will get me y times x minus 6 is equal to 18. Now that I've isolated the y on the left-hand side, I just need to get rid of this factor of x minus 6. So I'll divide both sides by x minus 6 to get y equals 18 over x minus 6. And since we've solved the equation for y, that tells me that the right-hand side is the formula for the inverse function. So f inverse of x is equal to 18 over x minus 6. And so that would be our answer. The final step of the 4-step process is to look back at what we've done. One of the things we look back for is a check on our answer. So is there any way that we could check that this is the inverse? Well, we could go back to the definition that said that inverse functions compose with each other to get x. And so, by way of checking, I'm going to see whether or not f of f inverse of x is indeed x. So let's see. We have f of f inverse of x. Now the formula for f is right here. And so f of f inverse is going to be 18 divided by f inverse plus 6. If we substitute the formula for f inverse we had, we're going to have 18 divided by the expression 18 over x minus 6 plus 6. So this expression here is a complex fraction, a fraction inside of a fraction. To divide by 18 over x minus 6 is to multiply by x minus 6 over 18. So the 18s will cancel. That will leave me with x minus 6 plus 6. X minus 6 plus 6 will cancel, and that'll leave me with an x. And so I know that this works. Another technique for looking back at a problem would be to see if there are any other way to go around and solve it. For example, is there any alternate method that we could have used to solve this equation? So if I had y equals 18 over x plus 6, we knew the process was to switch x and y, so x is equal to 18 over y plus 6. We subtracted 6 from both sides to get to x minus 6 equals 18 over y. At this point, though, you might have done something different than I did. Instead of cross-multiplying both sides by y, you might have noticed that if we took the reciprocal of both sides, which means raising it to the negative first power, on the right-hand side, we would have gotten y over 18. Which have been very close to solving for y. The left-hand side, we would have had the reciprocal of x minus 6, which is 1 over x minus 6. At this point, we could have multiplied both sides by 18. and we would have gotten 18 over x minus 6 is equal to y. And this is exactly what we got last time. So there's a slightly different approach to solving this problem. Now that we've done that work, let's actually go and write up a final solution. So I'm going to mark this first portion of the work as draft. And now let's do a final write-up of our solution. So we had y was equal to 18 over x plus 6, which was the starting of the process. We switched the roles of x and y, which was the second step in the process. And then we solved it for y. So we subtracted 6 from both sides. We multiplied both sides by a y. And then we divided both sides by an x minus 6, which was our final answer. F inverse equals 18 over x minus 6. And so we have a solution. And so there we have our final answer. That means we've now handled 2 of the 3 example problems. So why don't you join us next time, and we'll finish up the third of these example problems. And hopefully you'll have a better appreciation of how homework should be written up and the process we should be always using as we go through these.